Welcome to the session on fractions, multiplication. The objectives of this session are to understand the concept of a fraction, multiply a fraction by a whole number, and multiply two fractions by each other. Let's recall the terminology of fractions. We will look at what the numerator and denominator of a fraction are. If we have a fraction 3 out of 8, this fraction represents, for example, 3 pieces of a circular pie which is cut up into 8 pieces. The value on the top part of the fraction is known as the numerator, and the value on the bottom part of the fraction is known as the denominator. In this example, the numerator is 3 and the denominator is 8. The fraction 3 over 8 can also be represented as, for example, 3 stars out of 8 stars, or 3 parts of an interval out of 8 parts of an interval. We will now consider what happens when we multiply a fraction by a whole number. Let's take a look at the example shown on your screen, namely 5 times 1/3. Let's look at solving this with the aid of diagrams. 1/3 will look something like the diagram shown. If we multiply 1/3 by 5, then this is equivalent to 1/3 being added to itself 5 times, or alternatively represented by the boxes shown on your screen. 3 of those boxes are equivalent to the whole as shown, and the 2 remaining boxes are equivalent to 2/3 of a box as shown here. This can be also called 1 and 2/3, so 1 whole and 2/3. If we would like to carry this out without diagrams, we multiply the whole number by the number of the numerator in the fraction and leave the denominator alone to give 5 times 1 over 3, or 5 over 3. Let's take a look at another example, namely 4 times 3/8. Again, let's take a look at solving this with the aid of diagrams. 3/8 will look something like the diagram shown on your screen. If we multiply 3/8 by 4, then this is equivalent to 3/8 being added to itself 4 times, or alternatively represented by the 4 circles shown on your screen. This is equivalent to 12 parts out of 8, or 1 whole and 1/2. If we would like to carry this out without diagrams, multiply the whole number by the numerator of the fraction, as shown, and leave the denominator alone to give 12 over 8. Divide the numerator and denominator by 4, because 4 is a number which is common to both, or which can be divided into both. So 12 divided by 4 of course gives 3, and 8 divided by 4 gives 2. And so we have 3 over 2, which is of course 1.5. Let's take a look at another example, namely 5 times 3/5. Again, let's look at solving this with the aid of diagrams. 3/5 will look something like the diagram shown. If we multiply 3/5 by 5, then this is equivalent to 3/5 being added to itself 5 times, or alternatively represented by the 5 rectangles shown on your screen. This is equivalent to 15 parts out of 5. And 15 parts divided by 5 is of course 3. If we would like to carry this out without the use of diagrams, multiply the whole number by the numerator of the fraction and leave the denominator alone to give 15 over 5. And 15 over 5 is of course 3. When multiplying two fractions, we simply multiply the numerator by the numerator and the denominator by the denominator. Let's try the example shown on the screen. We multiply the numerator by the numerator, so 4 times 3, and the denominator by the denominator, so 7 times 8, as shown, to give 12 over 56. We then divide the numerator and denominator by 4, since both 12 and 56 are divisible by 4, to get it in its lowest form. In other words, 3 over 14. Now let's multiply three fractions by one another. Let's try the example shown on the screen. We multiply the numerators by the numerators, and we multiply the denominators by the denominators to give 1 times 4 times 3 in the numerator and 8 times 9 times 7 in the denominator. We can cancel at this stage to make the calculations easier later on. The 4 in the numerator will cancel using the 8 in the denominator, and the 3 in the numerator will cancel using the 9 in the denominator. This has made our calculations much easier, and we therefore obtain 1 out of 42. Now let's multiply three fractions by one another with one pair in brackets. Let's try the example shown on the screen. Considering the expression in the brackets first, we multiply the numerators by the numerators, or numerator by the numerator, to give 3 times 2, and we multiply the denominator by the denominator, in other words 8 times 7. We can cancel at this stage to make the calculations easier later on. The 2 in the denominator will cancel using the 8 in the denominator. To give 7 over 9 times 3 over 28. And the 3's in the numerator will cancel using the 9 in the denominator. And now the 7 in the numerator will cancel using the 28 in the denominator, as shown. This has made our calculations much easier, and we therefore obtain 1 out of 8. Now let's multiply three mixed fractions by one another with one pair in brackets. Let's try the example shown on the screen. Let's convert the mixed fractions to top-heavy or improper fractions. Let's begin with 2 and 1/3. Two wholes are represented by 6 over 3. And the 1/3 is of course 1/3, as shown here. So this now becomes 7 over 3. Similarly, let's convert 1 and 3/8 to top-heavy or improper fractions. One whole is represented by 8 over 8, and 3/8, of course, is just 3/8. Add these together to give 11 over 8. Similarly, let's convert 3 and 2/7 to top-heavy or improper fractions. 3 wholes are represented by 21 over 7, and the 2/7 is of course just 2/7. Add these together to give 23 over 7. As we are dealing with multiplication, we do not require the brackets. Now we can cancel the 7's and then multiply the numerators together and the denominators together. Multiplying the numerators gives 253, and multiplying the denominators gives 24. 253 divided by 24 gives 10, remainder 13. The commutative property of multiplication of fractions holds. Don't be worried about the word commutative. It simply means that if we have, for example, the example you can see on your screen, we will have 3 over 7 times 4 over 9. This can also be expressed as 4 over 9 times 3 over 7. Let's see if we can verify this. First, let's expand or multiply out the left-hand side. Doing so gives us 3 times 4 divided by 7 times 9. The 3's in the numerator cancel out using the 9 in the denominator. Carrying out the multiplication gives 4 over 21. Similarly, multiplying out the right-hand side gives 4 times 3 divided by 9 times 7. The 3 in the numerator cancels out using the 9 in the denominator. And carrying out the multiplication gives 4 out of 21. And we have therefore proved that the left-hand side equals the right-hand side, and that for this example, multiplication of fractions is commutative. Now let's have a go at the example on your screen. We need to prove or show that the two sides of the equation are actually equal. Let's take a look at the left-hand side first, as we did in the previous example. So, looking at the bit in the brackets first, we can see that the 3's in the numerator and the denominator cancel out, as shown, to give 2/3 times 1 over 7. And multiplying this out gives us 2 over 21. Similarly, on the right-hand side in brackets, the 3's cancel, as shown, to give 2 out of 21, and we have therefore proved that the left-hand side equals the right-hand side, and that for this example, multiplication of fractions is what we call associative. This brings us to the end of this session. If you have understood its contents, you should be able to multiply fractions by a number and multiply two or more fractions, proper, improper, and mixed, involving brackets. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time, so you can check your answers as you go along. Pause the slideshow whenever you need to. And now for these exercises. Again, the solutions will be released one at a time. And now for these exercises. And these exercises. And these exercises. And these exercises. and finally these exercises. For further exercises, do check out the exercises in your textbook related to this topic. Thank you very much for listening.